Welcome to part 3 of Competency 13. In this video, we will work with areas and portions of circles. Okay, before we begin, let's look at our diagram and our two equations with it. Okay, what this is saying is that your sector arc is proportional with the sector arc out of the entire circumference. Remember, pi d is circumference. We can set up a proportion. So this outside sector right here, this little bit right here. Oh, I don't need to draw on that. But your little outside area here with the sector over the entire circumference, which is part over total, equals the part over total of theta, the degrees. So you have whatever theta is out of 360. So just make a note of how that works. So you're setting up a proportion of part over total equals part over total. Same thing with the area of the sector. Sector area, now I have that in green, so it's color coded. The entire area is your total. So that's areas of the sector out of the area of the entire circle is equal to theta out of 360. So whatever theta is. So it doesn't matter. So that's a nice proportion. I know that we teach students in middle school, we teach a proportional setup. So this is a good way to, if you're a teacher, and to remember it yourself, but also say, okay, it's just a basic proportion. There's no reason why we can't just quickly learn this. Okay, and I see some fragments here. Okay, all right. So let's go to number 1. All right. Number 1, the radius of the circle is 4 units. What is the length of the arc of the sector for which the central angle is 60? Now that theta is the central angle, okay? If you didn't recognize the terminology. So we have 60 here. Now we need the arc. So we're going to call that x. If my x's were a little better. Okay. Okay. So then we need, if we're talking about the arc, talking about arc measure, then we have to talk about the total circumference. And that is 2 times r times pi. So 2 times 4 is 8. So put 8 there. Okay. Now, over here on the right with the angles, the arc, no, I'm sorry, not the arc, but our central angle and our total degrees, we can simplify that. And I know that is 1 out of 6, okay, just by looking. But just in case the numbers get dicey, remember, your calculator will give you that. So we have 60 divided by 360, push enter, and then second, oh, I'm sorry, not second, push that again. Okay, math, and then enter. And remember, see how it says answer fraction? You're changing it to a fraction, so push enter. And it is 1/6. Okay. Anyway, moving on. So now we have a way to quickly get, solve the proportion. So just basic algebra. So 6x, remember we cross multiply like this. Remember that from middle school? Okay. All right. So 6x equals 8 pi. Then we divide both, the coefficient, divide by the coefficient of 6. So now we get x equals, now that 8 over 6, I can already see what that is. But if you can't, it doesn't matter. If the numbers are large and dicey, that's not going to matter. You've got your calculator. So 8 divided by 6, push enter, then go back to math as before. It's highlighted on fraction, push enter, enter, and 4 over 3. Now, if your calculator isn't doing that, okay, I need to do this. Okay, it should be 4 pi over 3, which is option C. Okay, back to the calculator. You need to click mode and see what you have your calculator in. So see where it says fraction type? I'm going to arrow down. And I have mine set up in that manner. Okay. Right. So if your calculator isn't giving you after math what you need, it is a possibility that you need to come and change your mode. Okay. Because I've had that issue where I played around with it. And that's what you should do. You should get your calculator, start pushing buttons because you can always go online and figure out how to put it back. It's not tough. Utilize everything in your calculator. Okay. Right now, let's back out of mode. Okay, let's go to number 2. The radius of a circle is 10 units. What is the area if the sector is, okay, we're talking about the whole sector. It is 35 pi squared inches. That implies area. So this means here, I'm going to go ahead and just erase this. Let's highlight that. We are implying area of the sector. So let's go ahead and set that up. Okay, so I have 35 pi over, okay, it says, what is the measure of the central angle? I have the sector. However, do I have what I need for the area? That is a conundrum. I need this central angle, and I know that's over 360. Now, we're talking area. We know that we're going to have pi here, and it is r squared. Now, what do I do to get that? Now, well, let's think about this. How did I get that? Well, it's not a big deal. They gave us a radius. Oh my gosh. So we can just say that this is 100. I know sometimes students are like, but Miss, how do you get it? Well, it's right there in front of us, okay? All right. So now that we have that, what do we need to do? Well, over on the left side, that actually can be reduced. So let's get 35 divided by 100. Let's push enter and then math, enter, enter, and that gives us 7 over 20. Okay, now I have something I can work with. I can say that I have 20x equals, now I need 7 times 360, 360 times 7. Okay, and actually, you know what? I didn't even do that when I did this. I just did it like this. I said 7 times 360, and then after I got all that, I knew that I divide by 20. And then that would give me the value of x. So I've already got 320, 360 times 7. I have that answer. Now I just divide by 20, and that's 126, which is an option, and that's option D. Number 3, the length of an arc of a circle is 15 pi and the central angle is 5 pi over 6. What is the area of the circle? Okay, well, there's some things that we need to point out here. Okay, length of the arc. This means when we use this with our central angle, we will not be able to find what the question is actually asking. It's asking for the area. So we need to solve for the circumference first, and then we can use that radius to find the area. Okay. And as you know, I'm sure that you've done this before. You are given the area, and what you really need out of that is the radius. And then you use that radius to go find something else, some other part of the question that they're asking. And that's exactly what we're doing here. Okay, so I'm going to set it up like this. I'm going to say 2r pi equals, I'm going to have, okay, why that's doing that, I don't know. There it is. And I am going to call that C. I'm going to set it up so we don't forget because I have more than once forgotten. Okay, so we have 5 pi over 6 over here. And then our length is 15 pi. Now, we said we use our central angle, which for us is 5 pi over 6. It's in terms of pi, meaning it's in terms of radian. That means we need to take our 360 degrees and put that in terms of pi, also in radians, okay? All right, now, well, we need to clean up this right side, okay? So we have 5 pi over, well, 2 times 6 is 12, 12 pi. And then that can be cleaned up even further. We can cancel pi. Okay, so now cleaning that all up, what are we really working with? We are working with 15 pi over the circumference equals 5 over 12. Okay, now we cross multiply. That gives us 5c equals 12 times 15 pi. Divide both sides by that 5. Okay, and that will give me a circumference. And I will have a way to find my radius, okay? Leaving it in terms of pi. If you change all this to decimals, then you're going to have a mess. So this is one of those occasions where you need to do that. And I already see by canceling out that this is 36, but I'll go ahead and put that in the calculator. 12 times 15 divided by 5. That is 36. But now remember, this is circumference. So that's 2 times r times pi. So this 36, we need to divide that by 2, and we get a radius of 18. So the area of our entire circle is this. The area of the circle equals 18 squared pi. So take that 18, square that, and we get option C in terms of pi. Okay? All right. And kind of see how I did that. All right. Now, let's go to number 4. If AB equals 10, what is the approximate area of the shaded region? Okay, this particular question, there's a lot of parts to that. There's a lot of working parts going on, okay? So first, I'm going to say that's 10. Now, the conundrum here is that I have a special right triangle, okay? And we may even want to see if we can, well, let's see if we can squeeze this in. Yeah, I can. I can calculate it in the space we have. Okay, so because I know this hypotenuse of this right triangle, which is a special right triangle, I know it equals 10. I use the properties of right triangles, which there's 2 ways to see this, okay? I can say this is x, and this is x times square root of 2. Okay. Now, this is proportional, and it's true. And there's a couple ways to see this. This is one way. Okay. And this is the way that we need to look at this, okay? So if that is the case, if we have x square root of 2, what values would give us 10? Okay, and how can we use that to get the sides of the right triangle? Okay, well, looking at 10, I say 2 times 5 is 10. That's perfect. That will work. Well, how does that work? Well, it works like this. 5 square roots of 2 squared equals 10. You put that in the calculator, it works, okay? So 5 second square root of 2. Oh, I didn't square it. I'm sorry. Okay, let's go back up and grab it. And let's square the 2. There it is. Now that's 10, okay? So that tells me, looking at what I have here, okay? Because when we apply the Pythagorean theorem, okay, 2 would be squared, and then that would give us our 10, okay? So let's try this out. If I have 5, 2 squared as a radius, let's use our Pythagorean theorem in our calculator and see if it doesn't work out, okay? All right, second under the radical. Now I need parentheses. 5, and I need to put 2 under the radical again, okay? Arrow over, close your parentheses, then do your squared. Okay, remember, that's the radius. We're squaring the radius. Now we add, okay, in parentheses, 5 second radical, and arrow over, and then our parentheses, square that again. Now, when I push enter, we should have the hypotenuse equal to 10. And we do. So now we verified that we have a radius. Okay, with that radius, we can obtain the area of our triangle, which we'll need because we need to subtract that from the sector area. Okay, all right, so let's do that really quick. So we have, let's see here, area of our triangle equals, so that's pi r squared. So we need to take the 5 square roots of 2 and put that in front of pi. And what is that going to equal? Well, when we square that, okay, we haven't done that yet. I'm just going to go up. Oh, but if I do that, it won't work. Never mind. I need to do parentheses. I'm leading you down a path that you probably shouldn't go down. So let's not do that. So let's take our radius. Okay, I'm in parentheses because I'm going to have to square this. Okay, I'm squaring all of it. That's the difference, okay, from what I was doing before. Let's square this. Okay, that's 50. Okay, but the area of that triangle, we need to divide all that by 2. So 50 divided by 2. Oh, and I have pi in there. Why do I have pi in there? Okay, let's try that one more time. Not sure where pi came from, out of my brain. That is, we have base times height divided by 2. That's what we're doing. So because we have the base and height are equal, so that is the radius squared divided by 2. Okay, that is 50 divided by 2, which equals 25. So we know the area of that right special triangle, which is isosceles, will be 25 units. And I apologize for that pi. Not sure where that came from. Maybe I need to take a break. Okay, glad I'm not taking a test. All right, so let's move on. We need the area of the area of the sector. Okay, so we can get the area of the circle, so which leads us to the area of the sector, and then we need to do some subtracting. Okay, so we need the area of that sector, and we're going to call that X. And oh, that's where the pi came in my brain. Okay, we need to take 5 pi squared. I mean, 5 square roots of 2 squared pi. That's where it came from. Oh, so don't make the mistake I did. Don't mix these things up. Central angle is 90, and that's over 360. And I know that that is 1/4. If you're not sure about that, you can take 90 divided by 360, and then math, enter, enter, and you get 1/4. So that is correct. So now what do we have when we clean everything up? We have 4x equals. Now we know that when we square 5 square roots of 2 squared is 50. That will be 50 pi. And then we're dividing that by 4. Okay. So now we know that our sector area is, okay, I'm going to leave this as 50 pi. Actually, let's just write the X over here because we're running out of room. But I'm going to leave that in terms of pi. And I'm not even going to divide the 50 divided by 4 because I don't think that that's worth it. Okay, so what are we really doing? X is our sector area. So we need to take our sector area and subtract the area of the triangle. Okay, so let me spell this out for us. We need the, oh, sorry. Okay, area of the sector minus area of the triangle. Okay. Okay. So we know that is 50 over 4 pi minus 25. Okay. All right. So whatever that is, that's going to get, and our answers are in decimal form. Okay. So the minute we put all this in and change it to decimal form, I mean, the calculator will change it for us. We know exactly what we need. We know exactly what that's going to equal. Okay, so 50 divided by 4, second, carry it up gives us pi, and we'll subtract 25. Push enter, and the magic number is 14 point, do some rounding, 27. And that's option B. Okay, I would do that for yourself and clean it up, go through the process a little differently, maybe, draw it again so you have all those things in your brain. Now, if you don't know what the special right triangles are, just Google that, get those up, and play around with those and look at the different ways that this particular right triangle can be presented, okay, in its simplest form. Okay, now let's go to number 5. All right. It says if the measure of angle APB is 35 degrees and the radius is 16, which they have labeled for us in our diagram, which you don't always get a diagram. You'll have to draw it out. What is the approximate area of the shaded region? Well, we're doing exactly the same thing that we did before. However, we have a different situation. We have a side angle side situation because this will be an isosceles triangle. And so we have side angle side. And that implies to get the area of that triangle, we need to use the law of sine, which is this. And if you don't memorize or you don't know the laws of sine, you will have to look that up. And if you look on the formula sheet that they'll give you in your certification test, you have other laws of sine that apply to this. And then they have laws of cosine, but you will not have this, okay? And I would go look at that to verify what you do have on your formula sheet, okay? Okay, so we need the area of our triangle, which will be 1/2 times our two sides, which are 16. So I'm going to say 16 squared times the sine of our degree of 135. Okay. Now, you can actually put all this in the calculator as is and get that. But before we begin, we have to make sure that our calculator is in degree mode. Okay. All right. So let's do that mode. And it is not, it's in radian. And I need to go over and push enter. And it's highlighted. Second mode. There you go. So I am going to say 0.5 times 16 squared and sine 135, close my parentheses, and I get that area. Remember, this was area triangle. I labeled it. It's that triangle, so option B needs to go. That's the area of my triangle. So I need to say 90.51 rounded. Okay. All right. And we'll have it in our calculator if we need to go back and grab it real quick. Okay. So now what I do? Now I need to use the formulas that I know to get the area of that sector. Okay. So, and we also need the area of the circle. Oh my God, there's a lot of parts, a lot of working parts here. So area of our circle equals what? 16 squared pi, pi r squared. And that just so happens to be, well, 16 squared, that's 256 pi. Notice I am leaving a lot of things in pi. Sometimes it's better. In fact, I've found that in general, oh, my eraser's not working. Oh, now it works. Okay, technology to like about pi. Leaving things in terms of pi is often better, and wait till the end and let your calculator deal with that. And I say that just like I did number 4 above. The reason I did that is you will get a difference of decimals. You'll have a small error sometimes. And then you'll have answer choices that are very close. And it's upsetting because you have to go back and do everything all over. And look at number 4. Option A said 14.55. And yeah, that's enough of a difference that it probably wouldn't have messed with my world. But to avoid that, just leave everything in terms of pi. And I guarantee you, the people who wrote the test, that's what they're thinking. Okay, so let's continue. Now, what do we have to do? We have to use those equations, the proportional setup that was given to us. So I have my central angle is 135. And because that's in degrees, I'm going to leave my 360. Okay. And I don't know the area of the region, but now I know the area of the whole circle, which is 256 pi. Okay. Well, that's nice, right? So let's simplify our left side. 135 divided by the 360. Okay. I'm going to pull that out of decimal form by doing my second math. Uh-oh. I pushed the wrong thing. Let's get out of that. I want just, oh, I know what I did. I shouldn't have said second. I should have just said math for the fractions. See? And oh, it's still going to work. Nice. Push enter. And that is 3/8. Okay. So let's clean this up. We have AX equals, well, that's going to be 3 times 250. Okay, well, that's not working. Okay, 256 pi. Divide both sides by 8, and I will have my sector equaling, remember that's your sector, and then we have to subtract 90.51 from that, okay? All right, so 3 times 256 and divide that by 8, and we have 96 pi, which is correct. 96 pi. So now, what do we need? We need the area. We need the area of the sector minus area of the triangle, which equals 96 pi minus 90.51. Okay. I'm going to circle this, pull it all out. Okay. So let's put that in the calculator and see what happens. 96 second carry up minus 90.51 enter. Okay. So I get option C. Great. Okay. All right, and that is the last question in this video. Uh, I hope that the little mistakes I make help you see how easy it is, even if you've done these problems several times, which I have. There's still things that you can get confused with, your thinking can get off. So I hope I've taught you some things and how to use your calculator to keep those things straight. Oh, well, this is what I was doing. Let's keep myself in order. And I'm going to do this, this, and this. Anyway, if you like what we're doing, please like us, share us, and subscribe. I can't tell you how much we appreciate people who subscribe to our YouTube channel. It it's going to allow us to keep putting things up if we see those subscriptions coming. Okay, happy testing.